In our next section, we're going to look at the link aggregation configuration in GNOS, which is standardized based with 802.3 AD, which is Link Aggregation Control Protocol, or with no negotiation, similar to what would be the ether channel modes of on for no negotiation, active or passive for LACP. Now, in the case of GNOS configuration, specifically, the way that this is defined is with an aggregated Ethernet interface, which is defined as the AE interface. This is similar to iOS, what we have as the port channel interface. So in the case of iOS, we would go to the member links, we would issue the channel group command. Whatever the group number is, that becomes the port channel number. So for example, if we were to go to Catalyst, and let's say on those links that are connecting the 3560 to the EX2 switch, so over here on the right, on the Catalyst 3560 side, we're going to say that interfaces Fast Ethernet 02 and 03 are going to be put into a port channel, and then that is going to create our logical port channel interface. So on the Catalyst, if we show run interface Fast Ethernet 2 and show run interface Fast Ethernet 3, we can see right now that these ports are layer 2 switch ports. They're trunks that are using .1Q encapsulation. If we were to go to global config and say interface range, Fast Ethernet 2 to 3, and issue the channel group command, whatever number that we define, for example, number 10, we specify the mode. This determines how we are doing negotiation. Now, of the negotiation protocols, we have port aggregation protocol and a link aggregation control protocol. This one here is the standard, which is defined as 802.3 AD. This is the one that GNOS supports as well. So PAGP is proprietary. You would not use that for interoperability between on the links, the aggregation of the links between the two different vendors' equipment. So in the case of Cisco, we would either say the mode is on, the mode is active or passive, where typically you would want to run LACP, you would either set the link as active or passive. So in this case, I'm going to say that the link is passive. That's going to mean that the GNOS side is in charge of doing the link aggregation. Okay, we see that when we issue the channel group number, this is also going to create the logical port channel interface. And if we show run interface port channel 10 should inherit the properties that were on the members. So if we look at the show run interface Fast Ethernet 2, and if actually I think in this version it does not because of an order of operations issue. Let's say on the channel interface, the trunk encapsulation is .1Q and the mode is trunk. And we show run interface port channel 10. In most versions, it's supposed to replicate that config, but in this particular case, it didn't. But in any case, you do want to make sure that the members always have the same configuration as the link aggregation, of the lag. Otherwise, the members can't be part of the channel if their configurations are different. Now, in the case of GNOS, it natively prevents this, because the only attribute that you have under the member interface is that it's part of the lag. Where specifically the way that we do this is by going under the interface and setting the ether-options, and then we say we want to run 802.3 AD, which basically means to run a lag, and that we're going to use the interface aggregatable Ethernet or aggregated Ethernet 0. Now, the other thing that's specific to note about this is that we cannot manually define these AE interface numbers. They're going to be defined automatically when we set this attribute here, which is set chassis aggregated devices Ethernet device count. If we were to say that this is 10, then the platform is automatically going to generate interfaces AE0 through AE9. So every time you want to add a new lag, you have to go to this global option under chassis aggregated devices and then increase this number. So if we were to do this on the EX side, let's say on EX2, and first we say globally, okay, so we're in config mode, we're going to edit chassis aggregated devices, set the Ethernet device count, and we'll say, for example, 5. We'll commit and quit. And then what we do, we're going to look at show interfaces let's say show interfaces terse pipe match AE. So this is generating 5 links. It's generating AE0 through AE4, but right now they don't have any member interfaces, so they're not actually doing anything. The verification for the lag itself, in the case of the Catalyst side, this would be the show ether channel summary, or in some versions this would be the show port channel summary. In the case of JunoS, this is going to be the show LACP interfaces. And right now it says LACP is not running because we don't have any members configured of the lag. Okay, so next we're going to go to our member interfaces and then essentially assign them to the lag. So there's 2 different sections here, the physical link, which is the member, and then the actual lag interface itself, which is, in our case, AE0. Technically, it could be anything AE0 through AE4, which we defined. But again, the point is that you don't generate these numbers. The platform generates them when you set the device count. So in this case, under the aggregated ether options, LACP active, this is the equivalent of the channel mode in the case of iOS. So we would say, under config, we're going to edit the interface AE0 and edit the aggregated ether options. Okay, if we set question mark, we can see this is where we configure LACP. So we'll say that the mode is going to be active. This also would be if you have multiple interfaces that you want to say which ones are going to be aggregated, which ones are not. You can set the system priority globally, and then you can also set the interface priority to say if you go beyond the number of maximum members of the lag and one of them fails, then a new member would be aggregated into it, similar to what you have in iOS. But normally you don't really need to set the system priority. What this is also going to control is who's in charge of doing the negotiation. So whoever has the lower value is the box that actually does the lag negotiation. Okay, so we set LACP active. If we show pipe compare, so far we went under the interface AE0, which again is the equivalent of the port channel, aggregated Ethernet options, and then we have LACP is configured as active. Okay, the other thing that you need to think about here when we're doing interoperability is that a lot of times there's a failure in speed and duplex negotiation when you go between different vendors or when you go between different platforms. So in general, when you are doing a lag, you normally want to set the speed of the duplex on both sides. So in the case of our particular design here, these are fast Ethernet interfaces on the Catalyst side, but they're gig interfaces on the JunoS side. So we want to make sure to hard code it on both sides to 100 meg full. Where in the case of Catalyst, we would just go physically to the port level, interface range faster than a 2 to 3, and say speed is 100 and duplex is full. In the case of JunoS, we could set this under the AE interface, which is going to be under edit aggregated ether options. So we would set the link speed to 100 meg, and set the, actually I think that's just the link speed. If we show pipe compare, so we have LACP and we have the link speed. And then also if we wanted to define what's the minimum number of links that we need. So maybe this is a link with 4 interfaces in the channel, and we say that the lag is only going to form if 2 of those interfaces are up. Then if 3 of the interfaces fail, then the lag is going to be torn down. And I want to say that by default the minimum links is 1, but we'll leave this off and see what the result of it is. Okay, then at the physical interfaces, if we top edit interfaces gig E00 22, and then this is going to be under set ether options. We'll edit ether options and set the link mode. That goes under the physical link, so full duplex. Same as on gig 23. That will then also say set 802.3 ID. Okay, so this is the equivalent of the channel group command. and then what is the interface that we want to aggregate it into. So it's going to be AE0. Now, when we do this, let's go ahead and let me do a commit check. I believe that we need to disable the other options on the link and then move them to the lag. So, for example, here in this case, the commit came back with an error. It says you cannot have unit 0 under the aggregated interface. That's because unit 0 is now going to be a property of the AE. It's not going to be a property of the physical link. So basically what we need to do is to delete the config that's under the members and then move that config to the AE. So if we look at, let's go up to and then say show gig E0022. Let's say show gig E0022 pipe display set. And I'm gonna copy this config out. Okay, so we'll hold on to this because we're going to move it to a different interface. And in the meantime, what we're going to do is to delete gig E0022 unit 0. And if we show gig E0023, that's the other interface that we're going to aggregate into, we would need to do the same thing. So we'll say edit gig E0023. I'm going to delete unit 0, and also delete disable. Okay, that's enabling the interface. Then if we top show pipe compare, again, this is showing our uncommitted changes. What I also need to do is to say on gig 23, under ether options, we're going to set the link to full duplex, and then I'm going to put it in the lag. So this is going to be under edit ether options. Set the link mode to full duplex, and set 8023 AD, and then what's the port number that we want to use. Top show pipe compare. And let's try that, commit and quit. Speed mismatch between AE0 and gig E0022. So I need to set the speed on the physical links too. So let's say set speed 100 meg. Okay, that would also be on top set interface gig E0022 ether options, speed 100 meg. Okay, next if we look at the show config, interface is AE0. The interface has the lag properties, but it doesn't have any of the address family configuration. So previously we were running Ethernet switching on it, and we were configuring the members as trunk ports that were allowing all VLANs. We now need to move this configuration from the member to the AE interface. Otherwise, it's not going to be behaving as a layer 2 port. So right now, if we look at the show Ethernet switching interfaces, we're not going to see interface AE0 forwarding any traffic. Because it's not configured as a layer 2 switch port. So this means that we need to now basically take those options that we had before, and we're going to move these to interface AE0. So AE0 unit 0 is going to be running Ethernet switching. It's also going to be a trunk. And then the VLAN members are going to be everything. Let's say run set CLI screen width a large value. Okay, so we're doing those two sets. So then if we show pipe compare, that should be setting essentially the port channel interface. Now this is configured as a trunk. So if we commit and quit, and what we want to see now on the Catalyst side, since we're running LACP, assuming that the lag is correct, we should see interfaces 2 and 3 come up, and we should see them join the port channel. On the Catalyst side, if we say show Ether channel summary, ultimately what we're looking for here is that this would say capital S, capital U for a switch port that is in use, and then we should see for the members, they should be capital P, which means that they're in the channel. Okay, but right now they're still down. So let's look at on the EX side. The way that we're going to verify this is with the show LACP neighbors, or show LACP interfaces. The output that we're looking for here is, and I don't remember offhand exactly what the statement is here, but it's under the mux state. When this here says detached, this is the equivalent of the channel being down. So right now the channel is not working for whatever reason. So let's look at here I think it says like collecting and distributing or something like that. Let's say show Ethernet switching interfaces AE0. Okay, so we can see it's configured as a trunk, but the state of the interface is down. Let's say show interfaces terse, pipe match, GigE00 22 and 23. Okay, this means that they're part of the aggregate. They're in the AENet, and it says the interface itself is AE0, and then the unit number is 0 because it's the main interface. Since the link is up-down, this means that it's some sort of configuration problem. It's not a problem with the physical link. If it was a physical link problem, it would be down-down. So we could try to flap it on the other side, but I believe that there's probably something still missing. Let's say show config, and let's just say show config. So we have under the chassis, that's the aggregated devices. So this is creating the interfaces that created AE0 through AE4. Then we have the interfaces are GigE0 22 to 23. So we have them set to 100 meg full duplex, and they're in the channel. Then we should have our AE interface. Aggregated Ethernet options, link speed is 100 meg, LACP is active. Let's show interface AE0 extensive. Okay, it says minimum links needed is 1. Let's try this. Let's move the same config over to the link between the two EX switches, and then we'll know if this is a config problem on the Juniper side or if it's an interoperability problem. So what may be a little bit easier to do is just to do this. Let's go to config, and let's say, actually before we do that, let's say show interfaces GigE006. And we're going to move this to the AE1 interface. So I'm going to say rename interface GigE006 to interface AE1. If we show pipe compare, now that's going to create that new interface. Okay, we'll do the same thing on the other side. We will rename interface GigE006 to AE1. We need to go under the chassis aggregated devices and set the device count, which again, this is creating the lag interface. The device count is 2. Then we're going to turn LACP on, so set interface AE1. That's the aggregated Ethernet options. Let's say we have LACP active on both sides. Then if we show the member interfaces, in this case the members are going to be GigE6 and 7. And we need to remove the rest of the config that was on the other member. So the easiest way to do this is just going to be to delete it. We'll say delete interface gigi 006 and 7. Then set interface gig E006 ether options 802.3 AD, and then the lag is AE1. Let's show pipe compare, pipe display set. Actually, no, we can't show compare. Let's say show so AE6 and 7, I need to add them to the lag. That's what's missing, which is these two. Okay, so we should get a log message here that the ports come up. And let's say show LACP interfaces. We should see AE1. Okay, so AE1 is running as a trunk. It's running as LACP active. And then if we show config interfaces gig E006 and 7, those should be the members of the port, which they are. Okay, same thing on the other side. If we commit failed, logical unit not allowed on the aggregated links, which is on show pipe compare. One of these members has one of the wrong options. I believe it is probably gig 7. Let's edit interfaces gigi 007 and then delete unit 0, commit and quit. So just like in the case of iOS, the config for this is very subject to the order of operations. So ideally, when you're creating the lag, you do it from the beginning to start, so then you never have to worry about moving the config from the members to the interface, or to the aggregated interface. In this particular case, the order is kind of screwed up because I already had config on there, and then I'm trying to rename it, trying to move it over. It would be cleaner just to create it from the beginning to start. Okay, so now it says what we're looking for is this output. It says the link became attached. If we now show LACP interfaces, collecting, distributing, this is the correct output. Basically, this means that the lag is up. If we now look at the show spanning tree bridge, we should see that the interface that is that we're forwarding out is AE1. So the same is true with Catalyst. When you do your verification for layer 2 port channel, one of the easiest way to check that the lag is up is to make sure that the spanning tree process only sees the logical link, that it doesn't see the underlying members. So I want to say, and let me compare these two configs. I want to say that this is going to be a speed negotiation problem between the Catalyst and the EX switch. So let's say show config display set. Let's just look at everything. Actually, let's say show config display set pipe no more. So this will say that's the equivalent of terminal length 0 in the case of iOS. So it's just it doesn't ask for the more output. So let's debug this config. Let's say, so what does not relate to it? Okay, the system stuff does not. The interface range does not. So let's group these together, the members and then the channel. So let's see, what is different? The first one, oh, interface AE1 doesn't have the speed set. I thought it did have, no, it's AE0 is what it is. This one is in AE0. The other one is AE1. Let's do this. Let's set the, I'm going to try deleting these two, the physical links, or the physical link speed and duplex, and let's see if just on the lag is enough. Speed mismatch between AE0 and gig 0022. Actually, let me do this. Let's delete it completely, and then we'll start it again. So let's say just this: delete interface AE0, delete interface gig 0022 and 23. Okay, let's start from there. Because now when we're creating the lag, it doesn't exist to begin with, and we can do it in the correct order. So let's leave out the speed and the duplex for now. So that should be, that basically is kind of like the minimum config. Interface status is down. And it also gave an error here. What did it say? Aggregated ether options, link speed mismatch detected. Aggregated ether options, link speed set to the kernel value of this. I think that's what's going to be the problem, because Juniper is trying to run it as gig, and the catalyst is at 100 meg. So I think if we set it under the lag interface to 100 meg, then the member should inherit it. So if we show interfaces AE0. Let's set it under here. Let's edit interfaces AE0, aggregated ether options, and then set the link speed to 100 meg. Commit. Now, if you're doing this in a real design, of course, this always depends on the platforms. So some platforms will have problems with negotiation, some of them won't. There's really no accurate way to predict all the time. You can just bring up the link and see if it works. If the link is down on both sides, then you know that you need to manually set it. So config checkout failed. Speed mismatch between AE0 and gig 0022. So where are we trying to, maybe it's an issue with the duplex. So let's say edit interface, let's go up to edit interface, gig 0, 22, edit, or no, set the speed. Then under Ether options, set the speed to 100 meg. Let's top edit interface gigi 0023 Ether options. Set the speed to 100 meg. Okay, so now the lag and the members are both 100 meg. Now it's up. Okay, we can see on the Catalyst side now that the member interface has joined the channel. And if we show Ether channel summary, we're looking for a capital P here, that these ports are in the channel. Then from the JunoOS side, if we show LACP interfaces, let's exit config, show LACP interfaces, collecting, distributing. This is the output that we're looking for. So once the lag is actually up, then we can configure the rest of the parameters on it. So technically, like the family and the trunking config, we don't need that to aggregate the port. The port aggregation is independent of that. So just like in the case of Catalyst, you can have a channel that is a layer 2 access port, could be a layer 2 trunk port, could be a layer 3 routed port, because the muxing of the data, like the actual load balancing is a function of the port. It's not a function of the upper layer options. But as you can see here, in this type of case, when you're going between platforms, sometimes you do have these compatibility issues. So the EX to EX, that was a pretty straightforward config. But when you're going either between link speeds or between vendors, or even sometimes you'll see like Catalyst has problems negotiating with even other Catalyst switches, you kind of just have to play around with the speed and duplex until you get to a variation that works. So if we show config, let's just look at show config. So again, there is under chassis, this is allowing us to do aggregation to begin with. Then under the interfaces, we're going to join them to the channel, or to the lag, which is to set 8023AD AE0. This is the equivalent of the channel group number command in iOS. Okay, whether the speed is needed or not, that depends on the platform. Then we have the AE0 interface. This is the logical channel. So we're saying LACP active. If we did not configure this, then the channel is going to have no negotiation. So on the iOS side, that would be channel mode is on. But in general, you always want to use LACP because it's going to prevent misconfiguration that could potentially cause a layer 2 loop in the network. Then we have the logical options, which are Ethernet switching, and we're doing a layer 2 trunk. From the Catalyst side, this config is pretty straightforward. If we show run interface fast Ethernet 2 and 3, it's simply that the channel group mode is defined, and then we have the layer 2 switch port configs.